Recently, accidents involving lifeboats and launching appliances have increased in number. As many as 125 accidents took place between 1989 and 2000, resulting in 12 persons losing their lives. Many of these accidents, which took place during regular onboard drills, can be attributed to lack of knowledge, lack of experience, and poor maintenance of the device by the crew. Typical causes of accidents include improper resetting of the lifeboat release device, inadvertent operation of the release handle, and cable rod malfunction. Following a spate of incidents, the SOLAS Convention was revised, and as of July 2006, annual inspections, servicing and repair are to be conducted by the manufacturer's representative or a person trained and certified by the manufacturer. In this DVD program, you will be shown operation and maintenance fundamentals for various types of life-saving appliances, with a focus on accident prevention. The guidelines introduced are general in nature. For a specific model or product, users are strongly advised to refer to the instruction manual provided by each manufacturer. Standards, specifications and functions applying to lifeboats are strictly regulated by the SOLAS Convention. Lifeboats covered by the 83 amendments include partially enclosed lifeboats, totally enclosed lifeboats, and totally enclosed fire-protected lifeboats that are equipped with water spray systems and air supply devices. Most lifeboats used on modern general merchant ships are of a totally enclosed design, i.e. they are covered with a canopy and have a propulsion engine. As for passenger ships, partially enclosed lifeboats are the most common. Ships with highly flammable cargo or handling toxic materials carry fire-protected lifeboats. All lifeboats have both offload and onload release functions, and simultaneous release of both ends is possible. Following enforcement of the 1996 amendment to the LSA code, all lifeboats are provided with an interlock mechanism to prevent accidental release before the lifeboat is waterborne. Totally enclosed lifeboats are usually launched using gravity-type davits. However, all bulk carriers built after July 2006 are required to have free-fall launching devices. To provide you with a better understanding of the structure and operations of various kinds of life-saving equipment, on this DVD we will deal with lifeboats, life rafts, rescue boats, life jackets, immersion suits, distress signals, and other accessories. Gravity-type davits swing a lifeboat outward and lower it into the water. They consist mainly of a pair of frames, davit arms, a lashing device, boat falls, suspension blocks, and boat winches. The lifeboat is lowered at a constant speed, using its own weight, by operating either the remote control wire inside the lifeboat or the remote control lever on the ship's deck. Let us take a closer look at lowering and launching operations for totally enclosed lifeboats with gravity-type davits. Prepare a set of transceivers and confirm that communication is possible. Also confirm that the cable for the storage battery charge has been detached. Confirm attachment of the painter to the Lifeboat's painter release device. The painter should be connected to the bit of the parent ship as far forward as practicable. Remove the overlashing wire ropes if fitted. Some vessels are not equipped with overlashing wire ropes. Overlashing wire ropes, once removed, should be kept together, but far enough away to prevent entanglement with the lifeboat. Tangling of the rope with the lifeboat could lead to a serious accident. The auto-trigger wire rope comes off automatically when the lifeboat is swung out. Pull out the safety pin to release the boat winch brake. Pull out the davit arm stop safety pins, both fore and aft, and release the stop by pulling down the handle in one continuous motion. Confirm that the remote control wire has been drawn into the lifeboat. Then open the access hatch and get on board. Once inside the lifeboat, immediately fit the bottom plug. Open the fuel valve and the cooling seawater valve. And close the drain valve on the exhaust pipe. Then confirm that all crew on board have fastened their seatbelts. The operator starts the engine and pulls down on the remote control wire to swing out the lifeboat. Once swing out is complete, fully pull down the remote control wire. The lifeboat will descend at a fixed speed using its own weight. As the lifeboat approaches the water's surface, the operator should alert the crew about impending splashdown. Avoid rapid swing-outs or abrupt halts during the swing-out operation, as this can have a dangerous impact on the boat. Inching operation is also dangerous, since it shakes the lifeboat. Lifeboat swing-out and lowering operation can also be conducted using the operation lever on the deck of the parent ship. There are two types of release for launching a lifeboat. One is the offload release, the standard method of launch and release, and the other is the onload release, which is to be conducted in emergency situations only. When the lifeboat is fully waterborne and there is no load on the release hook, carry out offload release. When the lifeboat is not fully waterborne and there is a load on the hook, onload release shall be performed. The release gear system comprises a pair of release hooks located fore and aft of the boat, a release handle on the side of the steering seat, a pair of control cables, a hydrostatic unit to prevent the lifeboat from plunging due to mishandling, and an interlock cable. There are two types of hydrostatic unit: a direct system that controls detected water pressure directly through an interlock cable, and an electric type that electrically controls the interlock lever with pressure signals to operate the relay and the solenoid. The interlock mechanism, which prevents a mishandled lifeboat from falling before it is fully waterborne, became mandatory for all lifeboats under the SOLAS 96 amendment. The offload release is an operation conducted when the lifeboat is fully waterborne and there is no load on the release hook. Prior to conducting this operation, the following should be confirmed. No ropes or lines are entangled on the fore and aft release hooks. The lifeboat is fully waterborne. The engine has been started. And finally, all crew are in their seats with their seat belts fastened. After all this has been confirmed, the operator releases the safety lock device, pulls out the release handle safety pin, and pulls the release handle to the fully open position in one continuous action. Some release gear systems do not have a safety lock device. In normal situations, the interlock unit detects the water pressure and releases the interlock when the boat is afloat, so it is possible to carry out an offload release using the release handle. However, in the event that the hooks have not released, it is necessary to conduct an onload release. The onload release should be reserved for emergency use only, when the hooks are not released due to malfunction of the hydrostatic unit, or when seas are rough and normal offload release is not advisable. To conduct an onload release, first open the cover of the interlock device. Fully raise the hydrostatic interlock lever and while holding it, insert the securing pin to release the interlock. Then, release the safety lock device. Next, remove the release handle safety pin and pull the release handle to the fully open position in one continuous action. Some release gear systems do not have a safety lock device. Release the painter and immediately get clear of the ship. Now let's look at the recovery operation. At least 3 persons are required for this operation. Accidents involving lifeboats often take place during recovery. Of these accidents, 70% are due to improper resetting of the release gear. As such, mastering the proper way to reset the release gear is extremely important. Properly resetting the release hook is an essential part of every recovery operation. Improper resetting may lead to the lifeboat being held by only one hook or even falling, resulting in a fatal accident. There are various types of release hooks. Regardless of type, improper resetting is indicated when the safety pin cannot be smoothly inserted or when extra force is required to return the release handle to the set position. If you have any doubts about the resetting operation, start over and redo each step in the process. To reset the release hooks, begin by pulling the release handle upward for about 30 degrees. Next, simultaneously lift the fore and aft hooks. After ensuring that the hooks have been reset properly, insert the safety pin. Finally, reset the safety lock device and make sure that it is in the locked position. The safety pin cannot be inserted unless the release handle is in its locked position. The reset procedure is the same no matter which type of release hook you are dealing with. Lift up both the fore and aft hooks and swing down the release hook reset levers. The release handle is automatically reset. Confirm that the release handle is fully reset and insert the safety pin. Next, insert the winch handbrake safety pin. Maneuver the lifeboat until it is under the boat falls. Using the winch, adjust the suspension links to the proper height. Simultaneously connect the suspension links to both the fore and aft hooks. Operate the winch using a remote controller and begin hoisting. Stop hoisting the lifeboat when it is just clear of the water, and confirm that the fore and aft hooks are properly connected. Also confirm that the hydrostatic interlock lever has been moved back to the locked position. Resume hoisting. When the davit arm approaches the stowed position, the davit arm strikes the limit switch and the boat winch stops automatically. Only after it has been confirmed that the winch has stopped completely may the crew disembark the lifeboat. Place 2 persons on the davit platform to oversee proper stowage. When the winch stops automatically, manually hoist the davit arm. Confirm that the davit arm is in contact with the platform stop and cease winding. Beware of overwinding. Do not forget to detach the manual hoisting handle once winding has been completed. Immediately reset the davit arm stop and insert the safety pin in the davit arm stop handle. After removing the handbrake safety pin, lower the suspension blocks on the davit horn by releasing the handbrake. If the suspension blocks are not on the davit horn, the boat falls will remain under tension and may be damaged. Insert the handbrake safety pin. Be sure to turn the end of the safety pin. Install the auto-trigger wire rope and use turnbuckles to tighten it. Install and tighten the overlashing wire rope. The painter should be kept attached to the painter release hook at all times. When using recovery straps in rough seas, connect the recovery strap between the release hook and suspension links. Once the lifeboat is out of the water, connect the maintenance wire to the release hook. Shift the boat's weight onto the maintenance wire. Remove the recovery straps and attach the suspension links to the hooks and execute the lifeboat recovery operation. Fire-protected lifeboats are totally enclosed lifeboats with water spray and air supply systems and are carried on ships such as tankers. The water spray system on fire-protected lifeboats effectively cools the surface of the boat envelope in order to protect the hull surface from fire damage and the cabin from high temperatures, thereby enabling the lifeboat and the crew to evacuate to a safe sea area if fire breaks out near the parent ship following an accident. The system protects the lifeboat and crew for at least 8 minutes. The spray system pumps seawater with a spray pump, ejecting it from nozzles on the external surface of the boat, cooling the hull. Before starting the operation, be sure to close the hatches and other openings and confirm that the main engine is idling. When preparations are completed, increase the RPM of the main engine and begin spraying. The air supply system protects the crew when they encounter a fire on the sea or are in an environment filled with toxic gas. In escaping from a hazardous area, all lifeboat openings are closed. The system provides clean air sufficient to operate the main engine and sustain the crew for not less than 10 minutes. Containers of highly compressed air found inside the lifeboat supply air to the lifeboat via a pressure regulator. During use, the valves on every compressed air container and the pressure check stop valve have to be opened. Confirm that pressure for air containers is maintained at the primary pressure gauge level indicated on the high pressure side of the air regulator. While observing the secondary pressure gauge level on the low pressure side of the air regulator, adjust the pressure using the regulator's handle so that the in-boat differential pressure indicator shows a pressure slightly higher than the external air pressure. Check that the air is being discharged. Now let's look at the free-fall lifeboat system. All bulk carriers of 500 gross tonnage and upwards built on or after July 1, 2006 are required to have a free-fall lifeboat. Free-fall lifeboats are placed at the ship's stern. In the event of an emergency, the crew board the lifeboat in its stowed position and then conduct a free-fall launch. The launching operation can be performed from inside the lifeboat. The Davit unit of a free-fall lifeboat consists mainly of a slide track, a davit arm, a pair of suspensions, a hydraulic cylinder, and a lashing device. The winch is composed of a wire drum, a hydraulic motor, speed reduction gear, and hydraulic brake gear. Prior to launch, make sure that the water surface is free of obstacles. Next, release the lashing line and confirm that the lashing plate has been released. The lashing plate will be released automatically once the lashing line is released. If the lashing plate is not released, release it manually using the attached nylon rope. Next, check that the battery charge cable has been detached. Then remove the release hook safety pin and open the rear hatch. The coxswain should confirm that all necessary launch preparations have been completed. The crew should then board the lifeboat from the rear hatch. Finally, the coxswain boards the lifeboat and closes the hatch tightly from inside. After everyone is on board, confirm that the boat's drain valve has been closed. All crew members should be seated, should fasten their seat belts, and should grasp the handrail on the seat in front of them. Do not forget to use the headrest belt if it is available. The operator should conduct a final check to confirm that all crew members have fastened their seat belts and that they have not put on life jackets. Then the operator may be seated and fasten his or her seat belt. When doing so, please avoid touching the release lever. The operator starts the engine. Removes the release lever securing pin and closes the bypass valve. Pumping the release lever several times releases the main lashing, allowing the lifeboat to achieve free-fall launch. Once the launch has been completed, immediately leave the parent ship for a safer area. Never use a painter during a free-fall launch. In the event the hydraulic system does not function properly and emergency release is required, confirm that the bypass valve is open. Break the acrylic cover. Insert the emergency release handle and turn the emergency release bolt clockwise until it comes to a stop. The stopper of the main lashing will open and the lifeboat will be launched. When a free fall is not possible due to insufficient water depth or when the ship is in an inappropriate area for a free fall, it is possible to lower and launch the lifeboat using davit arms. When launch preparations have been completed and confirmed, switch on the hydraulic power pack. Operate the control lever to lower the traverse and subsequently remove the hook lashing lines. Attach the wire ropes to the suspension. Using the lever, position the davit arms just above the boat lifting position and adjust the fore and aft balance of the lifeboat. The crew members embark the lifeboat from the rear hatch, take their seats and fasten their seat belts. Each member should grasp the handrail on the seat in front of them. The operator then boards the lifeboat and closes the hatch. The operator confirms that all crew members have fastened their seat belts and then removes the pin securing the release lever and closes the bypass valve. Pumping the lever several times releases the release hook and removes the main lashing. After visually confirming that the main lashing has been released, the operator on the main ship shall use the control lever to swing the davit arms to the proper lowering position and then lower the lifeboat. When the boat is waterborne and has become well balanced, the operator on board the lifeboat shall indicate to the operator on the parent ship to stop lowering the boat. The operator on board shall remove the wire ropes used to suspend the boat and attach them to the plate provided. The boat engine can now be started. Immediately leave the area of the main ship. Switch on the hydraulic power pack on the parent ship. The operator on deck uses the control lever to swing out the davit arms. Next, lower the suspensions to a height allowing the wire ropes for hanging the boat to be attached. These steps should be carried out under instruction from an operator on board the lifeboat. The operator on board the lifeboat attaches the wire ropes to the suspensions. After signalling to the operator on deck, the operator on board the lifeboat should be seated with seatbelt fastened and should stop the engine. The operator on deck confirms that the engine has been stopped and starts hoisting the boat. The movement of the traverse should be halted prior to coming into contact with the hinge block and the wire rope support. By operating the control lever, stow the davit arm to the boat set position. Station an operator on the platform. Stop the operation before the davit rear span and the boat come into contact. Using the control lever, lower the lifeboat until it is positioned on the roller. Raise and lower the lifeboat several times with the control lever, thus adjusting the stowed position until it is possible to attach the main lashing. Each operation should be implemented slowly and in concert with the signals provided by the operator stationed on the platform. Securely attach the main lashing to the release hook. After confirming that the main lashing is secure, the crew may disembark the lifeboat via the rear hatch. The operator on deck lowers the suspensions, detaches the wire ropes for hanging the boat, and attaches them to the plate provided. Using the control lever, move the davit arms to the stowing position. Although the davit arm stops moving when it comes into contact with the arm support, keep an eye on the davit arm during this operation. Attach the hook lashing lines to the suspensions. Set the lashing line. The lashing plate is set automatically once the lashing lines are attached. Turn off the power pack. The SOLAS Convention requires that all vessels equipped with free-fall lifeboats also carry rescue boats. There are three types of rescue boats: rigid, combined, and inflated, and all three have propulsion systems. Rescue boats on bulk carriers can be operated continuously for 4 hours at a speed of 6 knots. Rescue boats must have capacity for at least 5 seated people, plus room for 1 person lying on a stretcher. The crew put on anti-exposure suits. To maintain effective insulation against the elements, every part of the body, including the face, must be covered completely. Let's take a look at rescue boat davits. Launching operations using the davit can be performed both inside the rescue boat and on deck. The davit unit is mainly composed of a post stand, davit arm, a release hook, hydraulic power pack, and a winch. For any vessel carrying a free-fall lifeboat, rescue boat davits can also be used as Liferaft davits. The winch unit is composed of a wire drum, electric motor, speed reduction device, handbrake device, and a governor brake device. Lowering and launching of the lifeboat is possible by operating the slewing remote control wire, the inboard remote control wire, deck remote control wire, and the handbrake device, which allows the lifeboat to descend at a fixed speed under its own weight. The rescue boat's automatic release hook is composed mainly of a hook reset lever, a release lever, an automatic release wire, and an on-load release wire. When lowering and launching a rescue boat, begin by switching on the power pack. Open the accumulator valve and confirm that the davit slewing area is free of obstacles. Confirm that the slewing remote control wire and the inboard remote control wire have been drawn into the boat. Confirm that the boat hanging wire is attached to the release hook and that the painter is set to the painter releasing device, which is located at the bow of the rescue boat. Remove the lashing wire rope. Remove the safety pin from the handbrake device on the winch. Board the crew. The operator on deck uses the hoisting switch to raise the boat free of its stand. During hoisting, swing out, launching and release of the rescue boat, the operator on deck shall stabilize the boat using the painter. The crew on board the rescue boat pull the slewing remote control wire and slew the davit to the lowering position. Slewing stops when the operator's hand is removed from the slewing remote control wire. Prior to slewing and lowering of the rescue boat, ensure that the tricing line has not become entangled with the boat. If the power supply is cut off, pressure stored in the accumulator can be used to complete the operation. However, if the amount of stored pressure is insufficient, slew the davit manually with the hand pump. When the crew pulls the inboard remote control wire, the winch brake is released and the boat begins to descend. After making contact with the surface of the sea, the automatic release wire should be pulled to release the rescue boat. After starting the engine, release the painter releasing device and proceed with the rescue. The operator can also lower the boat by pulling the deck remote control wire or lifting the brake lever on deck. In the case of automatic release, pull the automatic release wire to bring it into the set position for automatic release mode prior to making contact with the surface of the sea. As long as the hook is bearing a load, it will not open. Once the boat is waterborne, the hook will release automatically. For the sake of safety, pull the release wire after the boat is waterborne. If the automatic release hook does not function after making contact with the sea, pull the on-load release wire and release the hook. As in the case of automatic release operations, on-load release is carried out by pulling the automatic release wire into the set position for automatic release mode, pulling the on-load release wire, and releasing the hook. Insert the safety pin and lock the winch handbrake device. Attach the shackle of the boat hanging wire to the hook in the released position. Pull down the hook reset lever to reset. The release lever will be reset automatically in the locked position. Use the hoisting switch to raise the boat. Visually observe the operation until hoisting is stopped automatically by the limit switch. The operator should confirm that the boat slewing area is free of obstacles and then slew the davit to the stowed position, set the boat on the stand, and set the boat's lashing line. Check the power pack pressure gauge and, if necessary, recharge it to the specified pressure level. When the operation has been completed, close the accumulator valve. For recovery of a rescue boat in bad weather, use the recovery strap. When launching a rescue boat in bad weather, mount the recovery strap to the joint plate in advance. Also, prepare the hanging off pendant. Launch the rescue boat by following the standard rescue boat launching procedures. Remember, do not use the recovery strap for launching operations. When hoisting the rescue boat, attach the recovery strap to the boat link. Hoist the boat to a position where the hanging off pendant can be set and then set the hanging-off pendant. Slew the davit into a position where the boat can be pulled toward the ship and have the crew embark on the ship. Lower the boat until its full weight is borne by the hanging-off pendant and remove the recovery strap. Set the release hook to the boat link. Hoist the boat until its full weight is borne by the release hook and remove the hanging-off pendant. Slew the davit and store the boat. Various types of life rafts are currently in use, but we will focus our discussion mainly on life rafts that conform with the SOLAS 96 amendment. Made of synthetic fibre with synthetic rubber or polyurethane, life rafts are kept airtight and watertight. Featuring good stability and habitability, they have a structure that withstands harsh environments. They are normally folded and are kept stored in an FRP container. Life rafts carried on tankers are oil-proof and flame-proof, and some have a structure that prevents accumulation of static electricity. Life raft accessories include canopy light, room lamp, seawater battery, lithium battery, safety valve for chamber, inflation gear, sea anchor, retro reflecting tape, and boarding ramp. These items have specific applications for specific contingencies. Some are to be used at an early stage during launching and initial drifting. Some are employed to maintain the crew's physical strength while adrift, while others are used to maintain the life raft's performance. Still others are for transmitting distress signals. All life rafts conforming with SOLAS 96 have instruction stickers on the surfaces of their containers. One of the most commonly used life rafts is the dropping type, which is stowed on deck. The life raft container is placed on a cradle and is secured by a lashing wire with an automatic release device. Life rafts conforming to SOLAS 96 are of the weak link type, and the painter is attached to the painter connecting ring. An automatic wire and an operating wire are located at the painter's midpoint. The operating wire is connected to the painter inside the container. Some older types of life raft have a separate automatic wire or wires and painters and do not have a weak link. Manual dropping of a life raft is possible by pulling the release handle built into the cradle. The automatic release device has an automatic operating mechanism that is triggered by water pressure, it cannot be operated manually. Some older types of life raft feature an automatic release device with a manual dropping handle. A cradle with a weak link has one end of the weak link connected to the cradle and the other end either to the painter connecting ring or directly to the painter. When a ship sinks, tension is applied to the weak link and the link disconnects, separating the life raft from the ship. In an emergency situation, it is possible to manually initiate a gravity fall of the container along the inclined cradle. In this case, the operating wire is pulled and the inflation of the life raft is triggered, opening the container and allowing the life raft to inflate automatically. Some units allow inflation and discharge of the life raft by pulling the painter manually after dropping the life raft container. When the life raft is dropped manually, the ship and the life raft are moored to the painter, and no tension is applied to the weak link. As such, it is necessary to cut the painter after embarkation. Should the ship sink before the life raft can be dropped manually, hydraulic release equipment will be activated at a water depth of between 2 and 4 meters. The container's buoyancy causes the automatic wire to be pulled, inflating and discharging the life raft. At the time of inflation, the painter is disconnected from the ship upon activation of the hydraulic release equipment. The weak link is broken after the life raft is inflated. The painter and one end of the weak link are directly connected to the painter connecting ring on the hydraulic release equipment, while the other end of the weak link is secured to the ship. The operating wire is connected to the painter inside the container. The painter is directly connected to the painter connecting ring on the hydraulic release equipment, and the weak link connected at the midpoint on the painter is secured to the cradle. The operating wire is connected to the automatic wire inside the container. The painter is directly connected to the painter connecting ring of the hydraulic release equipment. The automatic wire is also directly but independently connected to the cradle. All of the following must be checked prior to drop launch of the life raft. Confirm that the life raft container is not lashed with a rope or other bond. Check that there is no paint obstructing the cradle's auxiliary rail rotating pin. Ensure that the painter is connected to the hydraulic release equipment. Check and confirm the connection of the weak link. Make sure that the safety pin is attached to the cradle's release handle. When boarding the life raft from the ship, use a ladder or boarding ramp. When climbing aboard from the water, use the boarding ramp or a ladder attached to the raft. It is also possible to jump from a height of not more than 4.5 meters onto the canopy. Pay attention to crew already in the raft. Do not board with tools, cutlery, or other objects that could damage the life raft. If the life raft should inflate in an inverted position, climb on the CO2 gas cylinder while taking hold of the righting rein on the bottom and apply your weight to turn it over to its normal position. One person can right the life raft. This operation is much easier if natural forces, wind and waves, are used. After boarding the raft is completed, remove the knife kept outside the canopy and cut the painter in such a way as to leave about 5 meters of it attached to the life raft. After separating the painter, recover the sea anchor that is tied near the external CO2 cylinder to avoid being caught in the whirlpool caused by sinking of the parent ship. Remove the paddles from the accessory bag, stick them out of the 2 openings in the boarding ramps, and row the raft according to instructions provided. Maintain sufficient distance from the ship to avoid being caught in the whirlpool. Only now should the sea anchor be redeployed. As an auxiliary measure, it is possible to move the life raft by dropping the sea anchor into the water and then pulling the life raft towards it. Initial procedures after boarding the life raft are described in the manual Instructions for Immediate Action, and it is strongly advised that these directions are followed. If the container is connected to the life raft and is floating, use a knife to sever the connection. Retro-reflecting tape, which makes a search from both sea and air easier, is attached to the surface of the life raft. In addition to this, prepare signals, radar reflector, dye marker to be used during daytime, etc. All of which can be found in the accessories bag. Now let's see how to launch a life raft using the Davit launching method. Under the Davit launching method, the container of the life raft is lifted by the davit, and the davit is turned to the life raft lowering position. By pulling the automatic wire, the life raft inflates, and the crew embark while the life raft is suspended above the deck. Using the davit, the life raft is then lowered, splashes down, and is released. The biggest advantage of the davit launching method is that it makes it possible for the crew to evacuate the parent ship without getting wet. In normal situations, the life raft container is stored on the deck cradle. The davit-assisted launch procedure for a life raft is the same as that for a rescue boat. Lowering and launching are possible with the operation of a winch remote control. Ships are often equipped with supplementary carry-and-drop type life rafts when standard lifeboats or life rafts are installed at distances from the bow or the stern of more than 100 meters. Automatic release devices are not required for carry-and-drop type life rafts. Some carry-and-drop type life rafts are equipped with an automatic release device, but they are used in the same manner as life rafts without an automatic release device. The life raft is carried to the dropping position where the painter is secured to the ship and the life raft is dropped. When the life raft is installed on a cradle with an automatic release device, set the painter and the automatic wire so that they do not hinder automatic flotation. It is essential that they are set according to the manual provided by the manufacturers. Now let's look at accessories for lifeboats and life rafts. The accessories are generally the same, though the contents may differ slightly depending on the capacity of the lifeboats and life rafts. Accessories common to lifeboats and life rafts. Rescue quoits. Sea anchor. Bailer. Food rations. Fresh water. Drinking vessel. First aid outfit. Anti-seasickness medicine. Seasickness bags. Thermal protective aids. Jackknife or safety knife. Tin openers. Whistle. Fishing tackle. Instructions for immediate action. Survival manual. Instructions for life-saving signals. Rocket parachute flares. Hand flares. Buoyant smoke signals. Waterproof electric torch. Daylight signaling mirror. Radar reflector. Sea dye marker. Special accessories for lifeboats. Buckets. Dipper. Hatchets. Compass. Painters. Oars. Toll pins. Clutches. Boat hooks. Engine repair tools. Portable fire extinguisher. Special accessories for life rafts. Paddles. Safety scissors. Sponges. Repair outfit. Topping up pump. Optional accessory. Desalinator. The satellite EPIRB is activated when it is removed from the installed position in the parent ship, and transmission starts automatically. The name and position of the vessel in distress, etc., are sent to the Earth stations via satellite. Should the ship sink, the EPIRB floats by itself and automatically begins transmission. The SAT radio transponder is used for search and rescue of survivors via GMDSS, Global Maritime Distress and Safety System. It receives transmissions from radar units installed on search and rescue boats, aircraft, etc., and transmits response signals. Visual signals are used as distress signals for vessels. A flash and a large amount of orange-colored smoke help identify the position of the vessel. Visual signals are required to have a useful life of 3 to 3.5 years and are stored in a special resin container. Signals, especially those made of gunpowder, should not be pointed towards a person, should be used only during an emergency, should not be put back in their container once the pull ring has been pulled, and should be used only for sending distress signals. Self-activating smoke signals are used either as distress signals for the parent ship or in order to indicate the position of a lifebuoy to a person overboard. They are tied to the lifebuoy when used. Once thrown into the sea, they self-activate and continuously produce smoke for 15 minutes or more. Buoyant smoke signals are designed for daylight signaling purposes on lifeboats and liferafts, and they continuously produce smoke for 3 minutes or more. The ignition is manual, and the performance is almost identical to self-activating smoke signals. Self-igniting lights are signals that automatically ignite when thrown into water. They continuously produce white light or flashes of 2 candelas for at least 2 hours. Like self-activating smoke signals, they are tied to a lifebuoy when used. Rocket parachute signals are launched by rockets to a height of over 300 meters. They descend with a parachute while producing a red flare of about 30,000 candelas for 40 seconds or more. Rocket star signals are launched by rockets to a height not less than 150 meters, producing red stars of about 250 candelas for 3 seconds or more. Remove the caps on the top and bottom. Remove the safety pin, then lift the ignition lever. To launch, while holding the body of the signal vertically, press the ignition lever in the rocket body with your palm. Hand flares indicate the position of lifeboats and liferafts. A red-colored flare of about 15,000 candelas is continuously produced for at least 1 minute. To ignite a hand flare, lift the grip and pull out the ignition cap. After ignition starts, hold it as far away from your body as possible, keeping it on the leeward side. The floating body of a lifebuoy is made mainly of cork. Those used for rapid release gear weigh 4 kilograms or more, and those for other devices weigh approximately 2.5 kilograms. Line-throwing appliances are capable of launching a line and reaching a distance of over 230 meters toward the distressed vessel. A set comprises 1 rocket-type launcher, 4 or more projectiles, and a line longer than 320 meters. Remove the front covers on the top and bottom. Remove the wire cord attached to each projectile. Connect the end of the rope at the back of the case to the ship's structure, handrail, etc. Remove the safety pin and pull the trigger. Following the amendment to the SOLAS Convention in July 2006, all cargo vessels of 500 gross tonnage and more shall be equipped with immersion suits in numbers sufficient for all persons on board. Immersion suits come in two types, those with inherent insulation and those with non-inherent insulation. Inherent insulation type suits, which exhibit high insulating performance, allow the wearer to survive for 6 hours in water as cold as 2 degrees Celsius. Non-inherent insulation suits allow the wearer to survive for 1 hour in water no colder than 5 degrees Celsius. Immersion suits are dry suits that cover the whole body with the exception of the face. Both inherent and non-inherent insulation suits are worn over clothing, and it is required that they can be unpacked and donned without assistance within 2 minutes. When donning an immersion suit, put your legs into the suit and then pull the suit up to cover the whole body, including the fingers. Finally, cover your head. There are both buoyant and non-buoyant immersion suits. Use a life jacket in conjunction with non-buoyant immersion suits. For the anti-exposure suit, priority is given to improved user movability and operability. As a trade-off, the materials used are less waterproof and less capable of retaining body heat. It is possible to survive for 1 hour in water of 5 degrees Celsius. It is required that life jackets can be donned without assistance within 1 minute, and they must also meet requirements for buoyancy and strength. They are designed to resist damage, and it is required that they will not be torn from the user's body even if the user jumps from a height of 4.5 meters. They will not injure the user either. 2 types of life jacket are available, rigid type and inflatable type. Rigid-type life jackets have a buoyant structure. After donning a rigid-type life jacket, the user secures it to the body with a cord or a buckle. Inflatable-type life jackets have 2 independent compartments that are inflated either manually or automatically. Should inflation be insufficient, use the auxiliary air supply device, which can be inflated by mouth. Life jacket lights come with the life jacket and can be turned on manually. They remain lit for 8 hours or longer. According to revised SOLAS, from 2010, all life jackets used on newly built vessels should be equipped with a buddy line to allow survivors to link themselves together and a lifting loop. Bandage-type life jackets will no longer be approved. This section deals with inspection and maintenance of life-saving appliances to be carried out by the crew on board a ship. As from July 2006, annual inspections, servicing and repair of lifeboats shall be conducted by the manufacturer's representative or a person appropriately trained and certified by the manufacturer. However, it is the responsibility of the crew on board to perform maintenance and inspection of life-saving appliances on the ship in order to ensure reliability of the equipment and to maintain effective operation. The crew shall carry out weekly and monthly inspections in accordance with the instructions for maintenance and inspection provided by manufacturers. Visual and operational inspections are required for the maintenance and inspection of lifeboats. External visual checks should look for obvious damage, scratches, cracks, deformations and other abnormalities, and confirm that devices such as the release gear are properly reset. Operational inspections shall be carried out for the release gear, painter releasing device, steering system and rudder, propeller, and so on. It is also necessary to check that there is no water leakage from the steering gear and the stern tube. Checkpoints for periodical maintenance work on engines includes the following: engine start, clutch operation, amount of fuel oil, of lubricating oil and of cooling water, leakage of fuel oil, of lubricating oil and of cooling fresh water, inspection and maintenance of gauges. As for electrical equipment, conduct inspection and maintenance of lights, electrical wiring, which may be loose, battery fluid levels, and voltage. Visually inspect all lifeboat davits for corrosion or rust, deformations, coating deformations and cracks, and check the operational condition. Also, lubricate moving components so that they function smoothly in an emergency. Coat the surface of boat falls and other wires with oil. During the inspection and maintenance of the boat winch, check the oil level of the gearbox and lubricate all moving components. Check the operational condition of the winch and the brake, and check that the winch is firmly fixed and that all wires have been wound correctly. Air supply devices for fire-protected lifeboats should be checked for corrosion of or leakage from the high-pressure pipe, and the volume of air in the compressed air container should be confirmed. The specified pressure is 17.7 to 19.6 megapascals. Water supply devices for fire-protected lifeboats should be inspected to confirm a smooth opening and closing of the ship bottom valve and normal rising of spray pump pressure. In addition, check clutch operation and belt tension while looking for corrosion of the spray pipe and clogging of the spray nozzle. It is strongly advised that the spray pipe be cleaned with fresh water after every use. Maintenance and inspection of free-fall lifeboats shall also be conducted in accordance with maintenance and inspection plans. Inspections of the release gear are of utmost significance, but attention should also be paid to equipment such as the launch device rollers. Moving components shall be periodically lubricated. Lubrication of the hydraulic cylinder is especially important. Additionally, confirm that the fixing part of the wire rope end is not loose and apply rope oil to the wire rope. Inspection of boat falls is important as well. In performing maintenance and inspection of life rafts, the cradle and container are the main targets. In accordance with the Maintenance and Inspection Manual, inspect the outer surface of the container visually and confirm that it is securely installed on the cradle, that it is not lashed with other ropes or bonds, and that the painter is connected to the connecting ring of the automatic release device. Make sure that rotating parts, sliding parts, and automatic release devices are free of paint, and that the safety pins are securely inserted. In addition, confirm that the water drain on the automatic release device is not clogged with paint or dust. Annual maintenance is required by regulations for life rafts too. Life rafts that come up for inspection during periodical maintenance shall be inspected and maintained at a certified servicing station. In order to maintain good performance, routine maintenance and inspection is essential. Proper knowledge of life-saving equipment, its handling and maintenance is essential if accidents are to be avoided during emergencies and live drills. Most accidents result from a lack of knowledge, improper handling, or improper maintenance. Therefore, effective education and repeated drilling in the use and care of life-saving equipment has become an issue of pressing concern. The purpose of this DVD is to prevent accidents caused by misuse of basic life-saving equipment. Equipment that is designed to save, not take your life. There are many manufacturers of life-saving equipment, and each piece of equipment has its own handling characteristics. Therefore, it is essential that every seafarer familiarize himself or herself with each piece of equipment and handle it in accordance with its operating manual.